we'll be starting with the next topic, which is our Buoyant forces, right? Buoyant force is nothing but it will use the exact same concepts which you have learned. Just दो तीन इसके rules हैं which you have to remember, and those are actually derived from the previous rules. हमने जो पहले अभी तक सीखा है उसी से will be deriving 2-3 rules for the Buoyant forces, and it is very much similar to what we have learned. So let's say there's some object. So ये हमारा कोई object है, some solid object which is inside fluid. So चारों तरफ से वो fluid से घिरा हुआ है. What do we know? That fluid is gonna apply force at every point of this object, correct? And what is the force applied by the fluid? That is pressure into area. So let's say the pressure at this point is P1. So if you take a dA1 area over here, so what's the force applied? P1 into dA1, PA. So this is this force applied by the liquid on the object, and it is perpendicular to the surface. This is all the things we've already learned, right? So similarly, we have normal forces. So these are normal reaction forces by the fluid applied on the object, correct? Now, what is Buoyant force then? Buoyant force is the vector sum of all the normal reactions of the surrounding connecting fluid. So surrounding connecting fluid जो भी normal reactions लगा रही है, this is P1 dA1, P2 dA2, P3 dA3, ये सारी जो forces लग रही हैं over the whole surface of the object, इनका जो वेक्टर सम अगर रख करोगे, so ये जो छोटे P1 ये PI into DAI, ये जो छोटे फोर्सेस हैं, इन सबको जब हम वेक्टर सम करके जो इनका नेट फोर्स निकालेंगे, that net force is nothing but our Buoyant force. So this net force, which is FB, we'll call it FP, the Buoyant force is equal to summation of all the normal reaction forces applied by the fluid. Correct? So you can also, since this is a sum over the entire surface, so you can also do a surface integral. So you can write it as integral over the surface P into dA. Now P, so if what you need to do, choose a point. P is the pressure at that point, and dA is its area vector. So this is my A vector, right? This is my dA vector, which is area vector, and the force, the normal force is opposite to the area vector because area vector is outwards, so force is inwards, right? So this is there would be a minus sign. So FB, which is my force, Buoyant force, is equals to minus surface integral P dA. This is done over the entire surface. Fine. So in very simple terms, this is my container. उसके अंदर fluid भरी हुई है, and there is an object. So fluid उस object पर कोई force लगाएगा. So this is how the fluid is applying forces on this object, right? और वो obviously perpendicular forces, perpendicular to the surface लगेगा. ये जो सब फोर्स का नेट फोर्स लगाओगे, नेट फोर्स जब हम निकालेंगे F net, that is nothing but my Buoyant force. So Buoyant force is nothing but the net force applied by the fluid on the object. As easy as that. So object पर fluid जो force लगाएगा, that is nothing but my Buoyant force. Fine. Buoyant force is due to the pressure difference inside the fluid. Why am I saying that? Because let's say the pressure in the fluid is same. अगर इस पूरे fluid में pressure हर जगह P है, so if you try to understand surface integral over dA, so this is actually mathematical, that surface integral over dA vectors over a closed surface. अगर closed surface में surface integral करोगे सारे dA vectors का, you will get a 0. ये मैथ से एक्चुअली आता है. सो इट इज बेसिकली व्हाट इट इज सेइंग इन मोर सिंपल टर्म, लेट्स से देयर इज अ स्फीयर और प्रेशर हर जगह P है. सो हर जगह P into dA फोर्सेस लग रहे हैं, राइट? नाउ बिकॉज हर जगह का प्रेशर सेम है, ये सारे फोर्सेस सेम है, एंड बिकॉज ऑफ सिमेट्री ये सारे फोर्सेस आपस में कैंसिल होके नेट फोर्स बिकम 0. दैट्स व्हाई Buoyant force is due to the pressure difference. Buoyant force pressure difference की वजह से होता है. फ्लूइड में जब प्रेशर डिफरेंस आएगा, कोई फोर्स बड़े होंगे, कोई फोर्स छोटे होंगे. इट्स लाइक दीज आर स्मॉलर गाइज एंड ये सारे फोर्सेस बड़े हैं, ये सारे फोर्सेस छोटे हैं. सो जब उनका इंटीग्रल सम करेंगे, उनका ये सब का वेक्टर सम करेंगे ये सारे फोर्सेस का, और अगर कुछ डिफरेंस होगा उनमें, तभी यू विल गेट अ नेट फोर्स. सो नेट फोर्स विच इज बायोंट फोर्स लाने के लिए यू नीड टू हैव प्रेशर डिफरेंसेस. करेक्ट. सो अगर प्रेशर डिफरेंस नहीं है, सो यू डोंट हैव एनी बायोंट फोर्स. देयर इज नो बायोंट फोर्स इफ देयर इज नो प्रेशर डिफरेंस. व्हाट डू वी नो? Gravity is something which creates pressure difference in the vertical direction. This is what we initially termed as pressure gradient, if you remember. So pressure gradient जब होगा means pressure की वैल्यू जब चेंज होगी तब बायोंट फोर्स एक्ट करेगा. बिकॉज बायोंट फोर्स क्या है? इट इज अ सरफेस इंटीग्रल, राइट. सो बायोंट फोर्स का नेट सम को नॉन जीरो आने के लिए यू नीड टू हैव सम डिफरेंस इन द प्रेशर which is created by pressure gradients. So gravity creates pressure in the vertical direction. So pressure gradient is in the downward direction. Hence the buoyant force which is acting is upwards. Why? Because okay, just take a very simple example. Pressure gradient नीचे है. So अगर इसके नॉर्मल फोर्सेस देखेंगे तो इस पॉइंट पर छोटे फोर्सेस लग रहे होंगे, और जैसे जैसे आप नीचे जाओगे सो फोर्सेस बड़े होते जाएंगे. करेक्ट. बिकॉज प्रेशर ग्रेडियंट नीचे है तो प्रेशर नीचे बढ़ रहा है. सो इन सारे फोर्सेस का जब हम नेट सम करेंगे सो यू विल गेट अ नेट इफेक्ट ऑफ अबव. दैट्स व्हाई बायोंट फोर्स इन द केस ऑफ ग्रेविटी acts upwards. So buoyant force is an upward force in the case where when the pressure gradient created is in the downward direction. Correct. So okay, this is when gravity creates the pressure gradient. Let's understand what happens. Okay, let's take this example. This is my fluid, gravity is acting downwards. So this is my object, right? So there is a pressure, there is a force from the above which is P1 into dA. There is a force from below which is P2 into dA. Now since pressure gradient is in the downward direction, this is my dou P over dou Y. So P2 into dA obviously बड़ा होगा. So the net force, अगर इन सारे forces का हम sum करेंगे, so the net force acting is upwards. So F net is in the upward direction. On the contrary, let's say this is my object. So this is my object. And the container is accelerating in the rightward direction. So acceleration of the container is this way. This is my acceleration. So we know that opposite to the acceleration, there's a pressure gradient which is created. So over here you have dou P over dou X. So pressure is increasing in this direction. Hence, there's a net buoyant force acting on the object in the rightward direction. So this is my FP. So the buoyant force acts in the right direction. Why? Because pressure gradient is in the left direction. So basically यहाँ पर प्रेशर लगाएंगे तो वो छोटे प्रेशर्स होंगे, यहाँ पर प्रेशर्स, यहाँ पर फोर्सेस बड़े होंगे, और बाकी सारे फोर्सेस कैंसिल हो जाएंगे, राइट. सो मीन्स इस डायरेक्शन में फोर्स कैंसिल हो जाएगा. सो इन इफेक्ट देयर इज अ नेट फोर्स इन द राइटवर्ड डायरेक्शन बिकॉज प्रेशर ग्रेडियंट is created in the leftward direction. So we can say that buoyant force acts opposite to the pressure. This is in opposite to the acceleration and it is in the direction of the pressure. So buoyant force acts in the direction of the pressure gradient. Okay, sorry, it was correct. Buoyant force acts opposite to the pressure gradient. It is in the direction of the acceleration because my pressure gradient is in this direction. So my buoyant force is opposite to the pressure gradient. And how to calculate pressure gradient we have already seen. So pressure gradient निकालेंगे and my buoyant force will be acting opposite to the pressure gradient. So let's take one more example. There is a cart which is having an acceleration in the rightward direction. So there is a gravity also in the downward direction. So this is G over here and A is over there. So if you try to find the pressure gradient in the fluid inside, so let's draw the pressure gradient. So there is mg force acting downward on the object not on the object, on the fluid. So there is an mg4 acting downwards, so there will be a pressure gradient rho into g in the downward direction. There is a pseudo force in the leftward direction, which is m into a. So pseudo force is m into a, so there is a pressure gradient in the leftward direction, which is rho into a. So there is some net pressure, this is rho into g effective. So this is my net pressure gradient. So pressure gradient is in this direction. Since the pressure gradient is in this direction, what would be the direction of the Buoyant force? So Buoyant force will act opposite to the pressure gradient. So the direction of Buoyant force would be this. So this is my Buoyant force. Buoyant force always acts opposite to the pressure gradient. This is my Buoyant force. Okay, so Buoyant force acts opposite to G effective. Now you can very clearly, so this is for you to just remember. आपको याद होगा, we've already studied it, what is G effective. So G effective is nothing but summation of the constant forces divided by mass. What do you mean by constant forces? Body पर लगने वाले स्थान से independent forces. So it's like those forces which are acting on the entire system as a whole. For example, this is my system, right? This is my entire system. So at every point, equal force is applied. At every point, equal force in the same direction is applied. Such forces are called स्थान से independent forces. And then net sum, और इनका जब हम net vector sum करेंगे, so by balancing the torque, there is a net force applied at the center of mass. So at the center of mass, so if this is gravity, we call it the center of mass. In a very similar way, we have pseudo forces. So pseudo forces are also स्थान से independent force, because pseudo force is acting on the entire body. Body के हर point पर pseudo force लगता है, which is dm into a, right? Body के हर point पर ये dm into a vector इतना force लगता है, and this is all are aligned in the same direction. And उनका जब वेक्टर सम करेंगे, so that is acting at the center of mass itself. So such forces are called स्थान से independent forces. And in order to calculate the G effective, we only take into account those स्थान से independent forces and divide by m in order to get the G effective. Correct? So as of now हमने पढ़ लिया what is Buoyant force. Buoyant force किस डायरेक्शन में लगता है. सो Buoyant force is because of pressure gradient inside the fluid. Buoyant force is nothing but the summation of all the normal forces by the fluid, and it is acting opposite to the pressure gradient. But how much? हमने देख लिया Buoyant force किस डायरेक्शन में लगता है, but कितना लगता है, what is the magnitude of Buoyant force. So let's try to calculate the magnitude of the Buoyant force. Okay, so in order to calculate the magnitude, again let's assume this is my object which is submerged inside the fluid. So हर direction में उसको pressure लग रहा है, right? So this is pressure forces acting perpendicular to its surface at every point. So fluid इस पे ऐसे pressure forces लगा रही है. So if there is, let's say there is rho into g, rho g pressure gradient downward direction में, so gravity is on, so there is a pressure gradient in downward direction. So we know that there is a net. So इन सब का जब हम vector sum करेंगे, so you will get a net FB upwards, right? You know this. But what is its magnitude? कितना लग रहा है? Let's try to find it out. Okay, now in order to find that, do one thing. Just remove this object out from the fluid. यहाँ से इसको खाली कर दो, just जादू करके इसे यहाँ से गायब कर दो. And instead of that, place a fluid element which is having the same shape and size as that of the object. So object का same shape, same size का एक fluid element उसकी जगह पे डाल दो. And which is made up of the same liquid, right? So this was liquid and this is also liquid. So उस ऑब्जेक्ट को बाहर निकालो and same shape and size का उसी जगह पे एक fluid का element डाल दो. Now the thing is, all these normal forces are same, exactly same as that. So ये इन दोनों diagrams में जो normal forces fluid लगा रही हैं, that is same. Why? The normal forces are same because normal forces are because of pressure gradient, and pressure gradient is defined by the fluid, right? So this is my connecting fluid. सिंस फोर्स नीचे लग रहा है, सो इस कनेक्टिंग फ्लूइड में इस पॉइंट पर क्या प्रेशर है, इस पॉइंट पर क्या प्रेशर है, इस पॉइंट पर क्या प्रेशर है. द प्रेशर्स एट दीज डिफरेंट पॉइंट्स ऑन द सर्फेस ऑफ द ऑब्जेक्ट, दोज प्रेशर्स आर हैव टू डू नथिंग विद द ऑब्जेक्ट इटसेल्फ. इसके अंदर क्या है डज नॉट मैटर. प्रेशर निकालने के लिए यू जस्ट रिमेंबर कि प्रेशर ग्रेडियंट कैसे निकालते हैं. डिफरेंस इन द प्रेशर इज डिफरेंस इन द हाइट्स टाइम रो इनटू जी, राइट. सो ये प्रेशर सारे यहां सेम है, इन दोनों सिनेरियो में प्रेशर्स आर सेम, सो ऑल दीज फोर्सेस आर सेम. So in order to calculate the net force, net effect of these forces, I can just balance out the forces. I can balance out the forces in this diagram. So look at this. So let me draw the free body diagram of this fluid element. So इस fluid element का free body diagram बनाते हैं. So this is my fluid element. Just pardon me for the shape. This is my fluid element, right? And the fluid element is experiencing the very first, so these are all the normal forces which are experienced by the fluid element because of the surrounding liquid, right? So surrounding liquid की वजह से ये सारे normal forces हैं, जिनकी वजह से there is a net upward force which is F into B acting on the fluid. The fluid is also experiencing a downward force which is dm into G. So this is mass of the fluid into gravity. Hence, Fb turns out to be mass. What is mass? Mass is density times volume times G. This is the magnitude of the Buoyant force which is acting on the object. Okay, so with this we've got to very important conclusion for this Buoyant force. The magnitude of the Buoyant force Fb is equals to, so Fb, the Buoyant force acting on an object, is equals to rho of the liquid, which is the density of the liquid, multiplied by volume of the object. This is important. Density of the liquid, volume of the object. See, you could have also written the volume of the fluid element, but volume of the fluid element is equals to volume of the object, because object का same shape and size का मैंने fluid element लिया था. So volume of the fluid element is equals to volume of the object into G. Rather than G, I am writing G effective because obviously now समझ चुके होंगे कि this G is nothing but G effective because it's G effective is like turning on the gravity in G effective's direction. So G effective की एक direction होगी, but Buoyant force acts opposite to the direction of the G effective, if you remember. So I am putting a minus sign here because G effective अगर नीचे है, so Buoyant force is acting upward on the object. So this is the formula you have to remember for the Buoyant force. So this is a very important formula for the Buoyant force, which says Fb is equals to minus rho Vg. Rho is the density of the liquid, V is the volume of the object, G is the G effective. So this is the conclusion. Buoyant force is equals to the weight of the liquid displaced by the object. What is this rho Vg? Rho Vg is nothing but dm into G, right? Weight of the liquid element. So Buoyant force is equals to the weight of the liquid displaced by the object. इस ऑब्जेक्ट को जब हमने पानी में डाला, so it displaced exact volume of the liquid out. So जितना weight liquid का इसने displace किया, the exact same is your Buoyant force. So Buoyant force is equals to the weight of the liquid displaced by the object. Very important to learn. Fb is equals to minus rho liquid, V object, G effective. Now there is a note. तैरने वाली वस्तु अपने वेट के बराबर वेट का लिक्विड डिस्प्लेस करती है. करेक्ट? Why am I saying this? What do you mean by तैरने वाली वस्तु? So let's understand this. So let's say you have a beaker and this is a beaker and there's a fluid inside the beaker. This is a fluid and there's an object जो कि तैर रहा है. Object का डूबना और object का तैरना are two different things. Object तैर रहा है means the object is somewhat like this. Let's say the object is of 6 kgs, right? So ये object यहाँ पर तैर रहा है. Object तैर रहा है means it is currently experiencing no acceleration. Its net force is 0. Its acceleration is 0. Correct? But what are the forces acting on this object? There are only two forces acting on the object. One are the forces by the fluids. So ये सारे जो normal contact forces हैं by the fluid elements. And one is the weight of the object. So this is W, weight of the object, which is M into G acting downwards. And we already know that these fluid elements together sum up to what we call as Buoyant force, Fp. Correct? Since this object is floating, ये object तैर रहा है, so उसका acceleration 0 है, which gives me Fb is equals to M into G, which is nothing but weight of the object. Therefore, तैरने वाली वस्तु, all the ones which are floating, अपने weight के बराबर का weight liquid displace करते हैं. So basically, this has displaced a liquid of this much volume, right? So this is the liquid which is displaced by the object. और उस liquid के weight के बराबर is what my Buoyant force is, right? What is Buoyant force? Buoyant force is equals to the weight of the liquid displaced. Buoyant force is equals to weight of the liquid displaced. Correct? अभी हमने देखा था. So Fb is equals to weight of the liquid displaced, which is weight of this much of the liquid. And that Fb is equals to weight of the object itself, mg. So इससे क्या पता चल गया? That weight of the object is equals to weight of the liquid displaced. But very important, this is in the case of floating. I'm repeating once again, floating is different. तैरना is different from डूबना. डूबने वाला case we'll see later. अभी हम तैरने वाला case देख रहे हैं. When the object is floating, weight of the object is equals to weight of the liquid displaced. So basically what I'm saying is, अगर हम same container लें, अगर हम same fluid लें, और इस टाइम ये जो फ्लूइड, ये जो बचा हुआ फ्लूइड है, इसका वेट एक्चुअली में 6 kg है. सो हमारा जो ये जब ऑब्जेक्ट यहां पर रखा गया तो इतना अमाउंट ऑफ फ्लूइड गेट्स अवे, इतना अमाउंट ऑफ फ्लूइड डिस्प्लेस हो गया और उस जगह पे ऑब्जेक्ट आ गया. ऑब्जेक्ट चूंकि 6 kg का था तो उसने 6 kg का वाटर को डिस्प्लेस किया, बिकॉज द ऑब्जेक्ट इज फ्लोटिंग, ऑब्जेक्ट तैर रहा है. द मोस्ट इंपॉर्टेंट थिंग. करेक्ट? नाउ देन द क्वेश्चन, अ वेरी इंटरेस्टिंग क्वेश्चन, क्या लोहा तैर सकता है? कैन आयरन फ्लोट? Okay, so let's try to answer this question. It is given to us that the density of iron is 7.87. So I'm just approximating it to be 8 gram per centimeter cube. So density of the iron is given to me and density of the water is given to me. So क्या कुछ ऐसा shape बना सकते हैं हम iron का जो कि उतना ही liquid displace करे जितना उसका खुद का weight हो? Did you understand it? Since I want my iron to float, मैं अपने लोहे को तैराना चाहता हूं. So in case of floating, if you remember, तैरने वाली वस्तु अपने वेट के बराबर वेट का लिक्विड डिस्प्लेस करती है. So can we make some iron shape out of it? It will displace the same volume, same amount of liquid, which is equals to its weight itself. So let's try to make it. let's take 8 kilograms. So over here, take 8 kilograms of iron. So this is my iron and this is 8 kilogram. So now what you need to do is to create a cuboid out of this 8 kilograms of 8 kilograms of iron, and the cuboid is hollow from inside, and this is iron, right? This is iron, this is iron, and inside it is hollow, there is nothing inside, in such a way that volume of the cuboid is exactly equals to 8000 centimeters cube. Why am I saying that? Because जब अब अगर इस क्यूबॉइड को मैं अब पानी के अंदर डालूंगा, so let's say this is my water, okay, this is my water surface, this is my surface of water, और जब इसको मैं पानी के अंदर डालूंगा, this is my liquid, the displaced liquid equals to its volume. Let's say it just floats, so this cuboid is just floating. It is not floating completely, it is just floating, means उसका upper जो surface है वो liquid के surface है just in contact, right? So this will displace some liquid जिसका volume is exactly 8000 centimeter cube, and a liquid having volume 8000 centimeter cube will have a weight of exactly 8 kgs, correct? And the peculiarity is weight of my iron is also 8 kg. Weight of my iron is 8 kg, weight of the liquid displaced is also 8 kg. So this will make my iron to float. So इससे ये जो लोहा है, it will just float, it will start floating because weight of the object is equals to weight of the liquid displaced by the object, and in that condition the object floats. Fine. So what we can remember for accelerating fluid? Okay, finally, so if the fluid is accelerating, so we can write that FB, which is my Buoyant force, is equals to rho of the liquid into V displaced into G factor, right? So this is G factor. This is something which we have already seen. This is volume of the liquid displaced. We had already seen that तैरने वाली वस्तु अपने weight के बराबर weight का liquid displace करती है. What about the डूबने वाली वस्तु? डूबने वाली वस्तु अपने वॉल्यूम के बराबर शेप का लिक्विड डिस्प्लेस करती है. See, this is something which we had seen in the very first, जब हमने Buoyant forces का मैग्नीट्यूड निकालने की कोशिश की थी. So this object is right now submerged completely. This object is submerged. So ये जो वस्तु है ये डूब रही है, right? और ये उतना ही लिक्विड डिस्प्लेस करी है. It has displaced the exact same amount of liquid which is having volume equals to the volume of the object. So डूबने वाली वस्तु अपने वॉल्यूम के हिसाब का फ्लूइड डिस्प्लेस करती है और तैरने वाली वस्तु अपने वेट के हिसाब का लिक्विड डिस्प्लेस करती है. So this is the difference you need to remember. तैरने वाली वस्तु is related with the weight of the liquid displaced, and डूबने वाली वस्तु is related to the volume of the liquid displaced. Just make sure, note this difference, right? There's a quick question, what is the point of application of the Buoyant force? Buoyant force, देखो Buoyant force is again, हमने उसका magnitude के बारे में देख लिया. उसका magnitude is equals to minus rho v volume of the liquid displaced into G effective. Direction is opposite to the G effective, right? So G effective के opposite लगती है. But the third important thing for force is point of application. So Buoyant force कहाँ लगता है? So Buoyant force acts on the center of mass of the displaced fluid. जो भी मेरा displaced fluid है उसके center of mass पे मेरा Buoyant force लगेगा, and this very particular point is called the point of buoyancy. This very particular point is called the point of buoyancy. So basically if you take a container over here और उसके अंदर if you fill it with a fluid और उसके अंदर एक tube, हम उसके अंदर just fill in a tube inside it. So this is my cylinder, this is my tube, right? Okay, so this way. So this is my cylinder. So cylinder का let's say cylinder की center of gravity कहीं यहाँ पर है. This is the center of gravity, center of mass of cylinder. So cylinder पे जब हम FBD बनाएंगे तो cylinder का यहाँ इस point पर लगेगा mg. This is mg acting downwards. बट बायोन फोर्स किस पॉइंट पे लगेगा? बायोन फोर्स का मैग्नीट्यूड तो हमने देख लिया. व्हाट वुड द मैग्नीट्यूड? मैग्नीट्यूड would be equals to the weight of the displaced liquid, and it will be in the upward direction because the pressure gradient is right now in the downward direction. But किस पॉइंट पे लगेगा? So look at this. This is my displaced fluid. ये जो fluid है, this small cylinder out over here, this is my displaced fluid. So इस displaced fluid का जो center of mass है, which is this point, इस point के ऊपर, इस point पर मेरा बायोन फोर्स लगेगा Fp. And so you now need to balance the torques, balance the forces. So basically जो भी मेरा ऑब्जेक्ट मैंने अंदर डाला है उसके, this is the point of buoyancy, this is the center of mass of the object. So you can just balance the torques, balance the forces out and see whether this is gonna topple out or not, torques balance हो रहे हैं या नहीं. What is the concept? Concept is center of mass of the displaced fluid पर हमारा बाउंड फोर्स लगता है, and that is called the point of buoyancy. Very next quick question. When cannot the concept of buoyancy be used? हम buoyancy को कब यूज नहीं कर सकते हैं? So when complete surface of object is not exposed to the fluid, then the force of buoyancy cannot be used. What do you mean by complete surface of the object is not exposed? So let's take this example. So this is my container. So okay, this is my container, and container is filled with fluid. Now the thing is, आपने एक object रखा है. So this is my object which is floating inside. But this object, this solid object is like this. This is my solid object, which is having some contact by the lower ground surface as well. So this is my object, right? So इस object पे जब हम बायोन forces देखेंगे, so what are the contact normal forces applied on this object by the fluid? So एक यहाँ पर, these are the forces which are applied. But जब हम इस object की FBD बनाने जाएंगे, so let's draw the FBD of my object over here. So इस object की FBD में, okay, so ऊपर से एक force आ रहा है because of fluid, so this is let's say P1A1. राइट से फोर्स आएगा, लेट्स से P2A2, एंड इस साइड से फोर्स आएगा, लेट्स कॉल इट P3A3. बट एंड ऑब्वियसली देयर इज mg एक्टिंग डाउनवर्ड्स, बट देयर इज वन मोर फोर्स व्हिच वी आर फॉरगेटिंग. देयर इज सम नॉर्मल फोर्स बाय द solid, by the ground as well. There is some normal force by the solid acting in the upward direction. So in this case, since all the surfaces of the solid are not in contact of the fluid, ये वाला जो नीचे का surface है solid का, that is in contact with the container, that is not in contact with the fluid. So you cannot apply buoyant force in this situation. इस situation में buoyant force नहीं लग सकता है. Why? Because obviously this n solid is also gonna come into the picture, right? And we do not know the magnitude of this. Okay, so in that case you would ask, then let's say this is again my container over here. अब इस container में this is my, it is filled with fluid, and let's say my object is floating. This is my fluid, and if I draw my object, let's say this object is floating. This is my object which is floating currently. So आप बोलोगे कि why? इस अभी भी हमें buoyant force तो नहीं लगाना चाहिए. The concept, why the concept of buoyant force was applicable over here? This is because this is a fluid, right? This is fluid, this is water, but this can also be assumed as a fluid since this is air. अगर air नहीं भी है, so we can assume air with pressure 0, right? So vacuum can also be assumed as air, a fluid with जिसका pressure 0 है. Or otherwise air है भी, so you can assume it to be a fluid. So in effect all the surfaces, in effect what you see is all the surfaces of a floating object can be assumed to be in contact with the fluid, so हम ऐसा मान सकते हैं कि all the surfaces are in contact with fluid. It does not matter whether the fluids are same or not. So this is my fluid 1, let's call it F1. This is my fluid 2, let's call it F2. So there are two different fluids acting. There are two different fluids which are in contact with my object. But even then, the concept of Buoyant forces is valid. Why? Okay, let's look at this. This is how the forces are applied by the air, right? So fluid number 2. This is how the forces are applied by fluid number 1, which is my water. So अगर इस ऑब्जेक्ट को मैं हटा दूंगा and if I do the same exact calculation which I did using this air and this is water, right? Air and water दोनों को मिला के if I do the same exact calculation, so what will I get? I'll get that Buoyant force, which is Fp, which is nothing but the net sum of all these red vectors, right? So this Fp is nothing but the net sum, which is summation of all the normal forces by the liquid, or which is F1, plus summation of all the normal forces by the air. So in sub normal forces का sum plus in sub normal forces का sum, this together will give me the total Buoyant force which is acting upwards. But see, this is so since we've already seen that this summation is equals to weight of the liquid displaced. This is equals to weight of the liquid displaced, right? Because अगर इसको हम हटा के इसकी जगह same shape and size का water element डाल देंगे, so that is balancing with these normal forces. So इन सारे normal forces का sum is equals to weight of the liquid displaced. इन सारे normal forces का sum would be equals to weight of the air displaced. क्योंकि वो भी तो एक फ्लूइड ही है. सो ये जो एयर का वेट है, दिस वेट ऑफ द एयर, इन सब का जब वेट लेंगे दैट इज इक्वल्स टू द वेक्टर सम ऑफ ऑल दीज नॉर्मल फोर्सेस बाय द एयर. एंड वी नो दैट वी कैन वेरी क्लियरली इग्नोर वेट ऑफ द एयर डिस्प्लेस्ड व्हेन वी आर टॉकिंग अबाउट वेट ऑफ द लिक्विड डिस्प्लेस्ड. हेंस इससे नेट इफेक्ट हमारा क्या आ जाता है, दैट Buoyant forces is equals to summation of weight of the liquid displaced, because weight of the air displaced is negligible in front of weight of the liquid displaced. Okay, so finally conclusion is, जब हमारे ऑब्जेक्ट के सारे सरफेस फ्लूइड, any fluid, it does not matter whether the fluid is same or not, any fluid के साथ कांटेक्ट में है या नहीं, अगर कोई भी एक सरफेस फ्लूइड के साथ कांटेक्ट में नहीं है, so you cannot apply the concepts of buoyancy. और अगर सारी सरफेस फ्लूइड के साथ कांटेक्ट में है, डज नॉट मैटर वेदर माय फ्लूइड्स आर सेम और नॉट, देन यू कैन वेरी क्लियरली अप्लाई द कॉन्सेप्ट्स ऑफ buoyancy. फाइन. सो दिस इज अ नोट यू नीड टू रिमेंबर दैट Buoyant फोर्सेस अगर FBD में हैं तो P into A वाले फोर्सेस FBD में नहीं होने चाहिए. Why? This is simply because PA, which is pressure into area, the normal forces, these are my PA force, right? P into DA. उन सब का resultant force ही तो Buoyant force होता है. So when you're drawing the fluid elements की FBD, अगर Buoyant force FBD में है, so P into A वाले forces FBD में नहीं होने चाहिए. Fine. So with this, all the concepts of Buoyant forces are done, and then we'll move to the questions related to Buoyant forces.